Good afternoon, everyone, and thank you for joining us today at our webinar on repair, restore and retrofit. My name is Lindsay Bridson and I am an Innovation Manager at the Construction Scotland Innovation Centre, and we'll be delighted to run this event for you today in conjunction with the Chartered Institute of Architectural Technologists. I'm going to tell you a brief bit from myself about the reasons for for the webinar today, and then I'm going to hand over to some of our panellists. So, just a bit of brief housekeeping first of all, though. This webinar will be recorded, so you will be able to catch up on it afterwards on our YouTube channel. It'll be loaded up by early next week. We would encourage questions. There's a Q&A session at the end of the webinar. You'll see a chat box there. That's how you can ask questions. Please don't feel that you have to wait to the end of the session to ask the questions. If there's something that you would like to ask about a particular presentation, then use the Q&A straight away. What we will do is we'll get through as many questions as we can. If we can't get through everything, what we'll do is we'll take a note of the questions and try and answer as many as we can afterwards as well, and issue them out to everyone who has attended. We will be running some poll questions as well. These will pop up on your screen automatically, and we'll get some quick feedback from yourselves about some topics related to today's webinar. And finally, I would just like to say that we will be issuing feedback after this as well. And we would really welcome any feedback you have about how you feel the webinar went, or how you think things could be improved for the future. So today, I'm joined by a really great panel today. We're joined by Oliver Hibbs from the Chartered Institute of Architectural Technologists, Graham Briggs from Historic Environment Scotland, John Stinson from Building Research Solutions, and Tanya Ewing from Glaze and Save. So what we're talking about today, I mean, I think most people on the call will be aware of the reasons for why retrofit is such a hot topic at the minute. There's a lot of reasons why retrofit is clearly very important, not least at all climate change and mitigation. Just some facts and figures here. It's been estimated that for the UK to have net zero homes by 2040, that requires approximately 28 million homes to be retrofitted. That is a sizable number. The estimated cost for that is over £500 billion, and that may increase with the way that things, materials and things like that are going at the minute. Just yesterday, there was a report out called Climate Ready Clyde, which was looking at the implications for basically making Glasgow and the surrounding area adapt to the implications of climate change. And one of the actions from that is the creation of a regional retrofit framework for climate resilience to ensure that the building stock is ready for the future. Other reasons for looking at retrofit, fuel poverty can be a huge issue in particular areas of the country, and if we can have homes that are more energy efficient, that's something that would really help address that. And one of the final reasons is for individual comfort and health of residents. There are a lot of studies going on at the minute in the field of healthy ageing and the positive implications for helping people to stay in their own homes and to avoid them getting into into hospital and the care system as well. And by looking at retrofit and making their homes more comfortable for they to live in, that's an important step for ensuring that people can stay in the comfort of their own homes, which has multiple benefits for them. But it's not just as simple as looking at going to the building and going, right, we need to retrofit that, let's crack on. If retrofit is done incorrectly, it can have very negative consequences. So what we're going to hear from today is to hear about some workflow involved, that whole system of restoring, repairing, and then retrofitting. We're going to look at the need to repair and conserve external fabrics. We're going to look at some of the tools and techniques that can be used. We're going to hear from a case study about an innovative product that can be helped to use to retrofit. And finally, we're going to discuss some of the consequences for what happens when retrofit is done incorrectly and what the implications for housing stock can be. So, to kick things off, what I'd like to do first of all is bring up our first poll. I've got joined by Danielle from our marketing team in the background, who'll bring that up for us. Thanks, Danielle. So you can see this pop up on your screen, and what we would like to know is what is the most important aspect of energy efficiency retrofit on historic buildings? And here we're talking about pre-1919. So you've got one there, you've got preservation of architectural features, lowest carbon dioxide emissions, reducing energy costs and fuel poverty, maintaining the use of the building, and return on investment. So we'll leave that up for about a few seconds to give everyone a chance to vote. And we should be getting the results for that fairly soon. There we go. Right, so you can see there, thank you for everyone that voted there. Quite a split the preservation of architectural features is the highest there, maintaining the use of the building. And then reducing energy costs and fuel poverty, and return on investment is low. That's an interesting one to see there. I think that's something that depends very much on who's asking that question. So thank you for that there. So what we'll do now is move on to our first speaker. So I would like to introduce Oliver Hibbs, who is the Chartered Institute of Architectural Technologists. Oliver is the Scotland East Secretary, and he is going to tell you a little bit about the work of the CIAT and also do a fuller introduction to the panelists for you today. So over to you, Oliver. I think you might still be on mute, Oliver. There we go.
Yeah, there we go. There we go. Good afternoon, everyone. Thank you for that introduction, Lindsay, and just like to welcome everyone along to this webinar. Yes, my name's Oliver Hibbs. I'm a Chartered Architectural Technologist, and I'm the CIAT Scotland East Secretary, as Lindsay said there. CIAT, which is the Chartered Institute of Architectural Technologists, is the governing institute for architectural technologists and supports students and professionals across a wide variety of industries, research and academia as well. And I think we will be sharing some links later on, but you'll be able to find out more about what the Institute and our region in particular does through our LinkedIn and Twitter feeds and through the Institute's website. But enough about me, more on to our speakers for today. So we'll be starting off with Graham Briggs, who is a Chartered Architectural Technologist and recently admitted fellow to the Institute as well. He also holds conservation accreditations as an architectural technologist and is working for Historic Environment Scotland as project manager with a focus on traditional materials and skills. Today he'll be discussing the need to repair and restore the external fabric before undertaking a retrofit project and looking at some of the common themes and issues when working with traditional buildings and how climate change is impacting our historic built environment. And next we'll be listening to John Stinson, who is an architectural technologist and the technical director at the Building Research Solutions. Over the past 14 years, John's delivered numerous technical papers working alongside Historic Environment Scotland and Retrofit Scotland and other conservation organisations. And today he'll be looking to describe some of the tools and techniques that assessors, designers and evaluators can use when undertaking energy efficient retrofit projects. And then finally we'll be hearing from Tanya Ewing, who is the CEO of Glaze and Save, who are an innovative and disruptive secondary glazing company. She bought the Glaze and Save's early stage product Invisifirm from the Procter Group back in 2014, and her background has meant that she's tackling the commercialization challenge in a very pragmatic way. She's also, as part of her contribution for advancements in technology in the built environment, been awarded an honorary PhD from Edinburgh Napier University. Today she's keen to share her thoughts on the industry, property conditions, climate change challenges, and her company's comprehensive approach to supporting their customers. So enough talking from me, I think. If I can pass back to Lindsay, hopefully, and she'll get Graham on and presenting for you. So that's all from me. Thank you.
Great. Thank you for that, Oliver. I appreciate the introduction. Yeah, as Oliver said, we are now going to hand it over to Graham, who will be running through from Historic Environment Scotland. Here we are. Right, Graham, we'll hand over to you.
Okay. Okay, so hello everyone. By now we all know that our climate is changing. You know, traditional buildings, while extremely resilient, they aren't immune to the effects of climate change. Since the 1960s, we've seen some dramatic weather. Just bear with me just one moment. Since the 1960s, we've seen some dramatic weather. And the image on the left-hand side describes some of the changes that we've experienced. We've experienced hotter, drier summers and warmer, wetter winters with more intense rainfall and occurrences of extreme weather. Now, the image on the right is from a website called Show Your Stripes, which is an image created by Professor Ed Hawkins from the University of Reading, and it's used to demonstrate in very simplistic terms the rise in global temperature across the time frame. Now, this image broadly represents a 1 degree rise in temperature since 1850. Now, 1 degree doesn't sound like a lot, but when you can see the dramatic effect that it's already having on our lives in the wider built environment, it is actually quite significant, and it's only expected to rise. So the West Coast in particular is seeing record levels of rainfall, and the climate change projections for the next 50 years, they're already locked in. There's nothing, we cannot change that. And this will have a dramatic impact on our built environment. So buildings will deteriorate more quickly, they'll require more maintenance, and we'll probably get to a point where we're going to have to make decisions and prioritize buildings that can be saved. Now, Historic Environment Scotland, we look after a number of scheduled ancient monuments, and these are also threatened by the effects of climate change. We have coastal sites that are at risk of rising sea level. We have sites that are deteriorating because of increased rainfall. Walls just aren't getting a chance to dry out, and this is decaying the masonry. And these buildings, they're made of materials that are extremely robust, but they just aren't immune from the effects of climate change. Now, Historic Environment Scotland have done a lot of work over the last few years that have really enhanced our knowledge and understanding of how to manage and mitigate the impacts of climate change. And there's a link there in the presentation that you can go on to when you get a bit more time. And it's worth just checking out to see what we're doing. Now, it's not just historic buildings or coastal sites that are affected by the threat of climate change. The entire built environment is too. The buildings we all own and live in, they're at risk. Buildings built today will deteriorate more quickly, and they'll require more frequent maintenance as our climate changes. So there is a need to make buildings more resilient in the face of this threat. So it really brings us to why we're here today, and it's something that Lindsay probably touched on better than I am. We're talking about the need to repair, restore and retrofit our existing building stock. Now, Scottish Government have pledged a net zero target of greenhouse gas emissions by 2045. Now, think about that. That's only 24 years away. So in 24 years, Scotland will or should be net zero, which means we won't be a net contributor to global CO2 emissions, which is great. But that's a big ask. There are 2.3 million dwellings in Scotland, of which 455,000 or so, 19% you may say, were built before 1919. Now, we refer to these as being traditionally constructed buildings. But this 19%, they've always been considered difficult to adapt, difficult to treat, and difficult to heat. But there's an urgent need to ensure that these existing buildings are part of the net zero solution and discussion. So now, if we look at those 455,000 buildings, many of them are tenements, houses, flats, and retrofitting even a quarter of these buildings over the next 24 years will be a huge challenge. Even if the financial resource was available to do it all now, there simply isn't the skills or physical resources available to do it at present levels. So I personally feel that this will become a huge growth sector in the next 25 years. And there is a big challenge in terms of ensuring the skills are available at both the professional and construction craft level. There needs to be a lot of upskilling, and retrofitting existing buildings needs to play a much bigger role in our education and training going forward if we are to realise net zero ambitions by 2045. Now, architectural technologists, as a profession that's detail oriented and focused on building physics, they're problem solvers. They're really well placed to play a leading role in this retrofit revolution. Their understanding the intervention and being able to qualify the impacts will be a big part of how this revolution moves forward. But before we go off and set about retrofitting 450,000 buildings, we must ensure that the external fabric of these existing buildings are in suitable condition to allow that retrofit to take place. Good maintenance, it's a prerequisite of energy efficiency. Now, this is an image that any of you have been on a HES talk by Roger Curtis or Moses Jenkins within Historic Environment Scotland. You'll have seen this before many times. The left-hand side of the image are some of the potential issues that occur when a building is poorly maintained. And on the right, there are numerous interventions or repairs outlined to ensure that the fabric of the building is working. And you can look at that in a bit more detail when you get a bit more time. But maintaining and repairing your building is probably the single most important thing you can do to improve its energy efficiency. And it should be a priority before any other improvements are considered. Buildings are more energy efficient when they are kept well. When loose, defective pointing poorly maintained windows, damp masonry, these all reduce the thermal performance of the building fabric and contribute to the heat loss and then result in increased energy costs. So, historically, our predecessors, maintenance of internal and external finishes was assumed. It was, it was a part of living and working in a traditional building, I suppose. But is this incompatible with modern day living? Like, who has the time or money to keep on top of maintaining their property? It's a big ask, particularly when there's so many, modern day distractions. But what we're finding is that more and more buildings aren't being properly maintained, and these problems, they build up, and something that could cost a couple of £100 today, if left untreated, can cause problems down the line, costing tens of thousands of pounds. So on many retrofit projects, delays and additional costs are incurred just due to uncovering things like rotten rafter ends, joist ends, damp patches in stonework, rusting metalwork, stuff that if it was repaired, it wouldn't need to be fixed as part of the retrofit process. So in short, sort of regular maintenance would result in many expensive retrofit projects, either not being required at all or saving a really good deal of money in those that are undertaken. So the takeaway from the talk today is to ensure that you deal with these issues before any thermal upgrading of the fabric takes place. And repairing and restoring the envelope is the first step in any retrofit project. And we'll just start by going down the areas of focus on the list on the left-hand side. So chimneys. Chimneys are generally the most exposed element of a building, and by their nature, they're typically hard to access. Consequently, they're often neglected. Not only are chimneys exposed to wind and rain, but flue gases and combustion projects deposited within the masonry over decades of time can accelerate the decay of the stonework or the brickwork. And this is exacerbated, particularly if the flues are no longer in use. Now, the chimney cans, if you look at the image on the left-hand side, you'll see that the haunching, it washes out, it becomes cracked, pots become loose. Now, this is not only dangerous, but it's something that probably needs to be fixed fairly urgently. And you walk around Edinburgh and you look up and see some of these chimneys, and you just know from looking at them, is that in a particularly great condition or not? You can see bits where things are growing out of them, and that there. So an important thing to look out for in these things is the chimney copes. Is there enough of an overhang or drip? Is the masonry degraded due to salts, wetness, spalling? Does it need rebuilding? In any case, it's sort of likely a chimney will need rebuilt every sort of 100 years or so, but it's a problem area, and this is something that is really the first thing when you approach a building, looking from the top down. As we come down the building, you'll see sort of things like skew copes. Now, these also face a high level exposure. They're hard to access. Defects can go unnoticed, and if left unattended, these can often become critical. These are there to protect the wall, the head of the wall. And if these don't work, then these can lead to progressive saturation of the gables, resulting in damage to the interiors as well as the exterior. But this also has a big impact on the thermal performance of the building. As we mentioned earlier, if the wall is wet, it's not going to perform as well thermally. So there's a number of measures that are outlined there that can be used. You can cloak or half cloak the skew cope. Now, that's an option, but in my opinion, it does detract from the appearance slightly. In some cases, the skew copes can be rebedded onto a lead damp-proof course, and it provides extra protection against water ingress. Now, if this approach is taken, the copes will need to be secured in place with additional fixings to avoid slippage, and the edges of the damp-proof courses should really extend out by about 2 inches or so, just to give a good drip there to shed water. But in many cases, just a good margin and a drip detail to shed the water is enough, and that's probably a preferable solution. And then we sort of come on to these parts of buildings, the parapet gutters. Now, these are a great trap for debris to build up. They're tricky to detail, and they do need a wee bit of thought. These can cause massive problems if left alone. So it's really important to regularly inspect them, clear them out. So you see on the left-hand side, the image, there's ponding, there's a slate sitting in the gutter. It's clearly not been looked after for a while. Now, the intervention on the right-hand side was to install a new stainless steel gutter. The lead work was carried over the parapet, and a guard was installed over the outlet to stop debris falling down the pipe. But that's that's the repair if it's sorted, but if it's not looked after, these problems will come back again. You know, and sort of moving down the building, we're onto roofs where, you know, many Scottish buildings have got roofs that are covered in a local stone or slate. Now, these are small, thick Scottish slates were produced from a range of local quarries across Scotland. The material was processed and produced in a variety of lengths and widths, and it was laid in diminishing courses, which, with the larger slates at the bottom of the roof, you know, and diminishing to smaller slates towards the top. Now, slates have got a finite life, but we know that this is a really robust material. You know, the material will last for well over 100 years, which is quite common. But, you know, depending on the type of slate and the quality of fixings and how the material has been laid. So, you know, we really are reliant on the craftspeople to help us understand these roofs. But similarly, regular repair is the best way to ensure that roof coverings will remain watertight and continue to perform well. So things really what you want to be checking is check for damaged, loose, missing slates. You know, the amount of water that can enter by a single missing slate is fairly limited, but it's the problems of the local decay of the sarking board that will follow that will lead to further loss of slates. You know, so generally an annual inspection and repair is sufficient. Other things to do is just check the flashings are clear of debris, valley gutters and things like that. There's no bits of slate or cement, you know, in there. Go into the roof space, you know, check the fixings. Are they good condition? You know, is there condensation on them? Is there moisture in the back of the sarking? You know, check for leaks in the roof. You know, it may not be obvious from looking outside where there's problems, but if you go into the roof space, you will see, you know, you'll get a better idea. And it simply just does come to a point. You'll see from the image there where there's quite a number of missing slates, and you might find that, you know, fixing these individual slates is no longer cost effective, so slating may be required. Now, as a general rule, you know, if you're talking more than 20-25% of slates are cracked, broken, or missing, you know, it may be more practical to just strip and re-roof the building. And, you know, I would suggest, you know, using an NRFC approved roofing contractor if you're going to go down this route. But, you know, there's something quite beautiful about a slate roof. I much prefer the lively tones of a traditional Scottish roof than the modern homogeneous roofing slates that we are importing today. You know, we've got plenty of these roofs around, but they are being lost at a fairly substantial rate. The material hasn't been produced in Scotland since the 1960s, so we are relying on imported material, which it just, to me, doesn't have the same appearance. You know, it's not quite as rough or as lively. You know, so for us, the best way to maintain and preserve these roofs is just regular maintenance, and you know, again, a sort of annual. You just go up and have a look at your roof through binoculars, and just sort of bring somebody out to repair it. You know, we get on to sort of roans and gutters, and these are a really important part of the building because, you know, they're the thing that carries rainwater from the roof. You know, ensuring that the fabric remains dry, the wall fabric remains dry. So, you know, if they get blocked, they can cause a huge amount of problems with high volumes of water saturating the building fabric. Now, this is a serious matter. If not addressed promptly, will result in damage to the masonry and finishes. You know, and it's one thing that I've noticed. If you go in any town centre or city centre, you look up and you see gutters with plants growing out of them, you know, with walls that are saturated or stained, you know, and it astounds me because you don't need to be a heritage or construction professional to know that plants shouldn't be growing out of gutters and water shouldn't be streaming out of walls just because the gutters are blocked. You know, it's simple stuff. You know, but we see it all too often. You know, if you look at the image there, you'll see the staining and plants just growing out of the gutter. So, you know, look after your gutters and they'll look after you. You know, cast iron rainwater goods, you know, they'll last several lifetimes if looked after and maintained. You know, they do get brittle, but, you know, I took my own ones down last year and it took 2 sections down at a time, and it took me about 6 months all told. You know, poorly maintained buildings, you know, they're vulnerable to damp problems. You know, however, with correct maintenance, repair, adequate ventilation, traditional buildings can be kept dry and healthy. I mean, you look at the image there, you might think that that's a huge job to keep this wall dry. You know, you've got your wind-driven rain to deal with, and then you've got the inside water loads of your showering, your washing and the vapor that we produce ourselves. So it's you've just got to accept that moisture is part of managing an existing building. And it's how we manage the movement of moisture out of the building and out of the walls is particularly important. So we've got to ensure that the materials that are there can breathe. They allow for water to be absorbed and then released. So any intervention here really needs to be thought through, as it will impact the point that moisture condenses within the wall buildup. So I would sort of advocate a really good understanding about how these walls work is a necessity before you kind of think about undertaking any retrofit measures. If you install, for example, you install a layer of insulation on the back of that masonry wall, it will make the back of that masonry wall colder, which will bring the dew point further into walls, which can cause further problems. But to address any damp problem, the source of moisture must be first identified and addressed before any interventions are considered. A lot of the work that I've done has just been simply removing cement render or cement pointing to stone buildings and replacing it with lime. Moisture just builds up behind the cement. It's nowhere to go. It causes all sorts of problems within the wall. It accelerates the decay of the stone. And it's really just, it's a hangover from a bygone time when people thought cement was great. It kept their buildings dry, but without realizing the problems that were building up behind the cement. So, making sure that this is a breathable construction is really important. And you'll always get the other extreme, where, mortar will fail, it'll wash out from time to time. These walls are starting to get a lot more of a hammering with the weather, and they're becoming more saturated, which is resulting in the decay. But what we've got to accept is that the mortar is a sacrificial element really to protect the stone. It will wash out, it will absorb moisture, but it needs to be repaired, maintained, like anything else. So if a bit of pointing falls out of your stone wall, it's important to get it fixed. And the other thing I would sort of advocate is like for like repairs. So anything you're doing to stone wall, you need to make sure that the materials are compatible with what's already there. And we'll touch on that a wee bit later on. And that kind of brings the question that we've been sort of thinking about is, to harl or not to harl. There's a lot of evidence to suggest that there was a lot more masonry harl traditionally than maybe we would think. But lime harl and lime washing makes these buildings much more resilient to extreme weather. But how do you balance that practical solution with the fact that you're fundamentally changing the appearance of the building, by installing a lime harl on a stone building? A lot of buildings maybe had this harl and it just became fashion. Stone became more fashionable. So it begs the question: do we need to go back to lime harling? If it makes the building more durable, it enhances the building visually, then perhaps why not? It's a technical solution. If it keeps our walls dry and it ensures the survival of the building, maybe we should consider it. And this is just a sort of example. It's the same issue with building stone. It's maybe this isn't a particularly attractive stone building, but I don't think the lime harl detracts from the appearance. I think it actually enhances it, and it's also offering a greater degree of protection. We're starting to get our way down to the very bottom of the buildings, and you'll see a lot of traditionally constructed buildings have got timber floors and they rely on a vented solum. It's very important to make sure that there's adequate air movement beneath these floors, because just to disperse water. And I've come across this in projects where I've seen so many of these vents covered, or the ground risen has been taken up right up to them, which isn't ideal. So I think it's important to think about the ground level and, has it been adapted? Should it be reduced? It may be practical to install a French drain there just to allow a bit of a wee bit more drainage to get to allow that to kind of move moisture away. And, this one's pretty self-explanatory, sort of below ground drainage, make sure your drains are clear. This is one thing that we probably do neglect. It's worth kind of making sure that if you do sort of see problems like you see in the image there, there's something going on there, and you maybe do need to think about investigating it further. But it sort of brings me to sort of some of the projects that I was going to talk about. This is a project that I worked on a few years ago in Anstruther. It's a it's a stone facade basically to an existing building. Now, you would look at the picture on the left-hand side and think, well, it doesn't look in too bad condition, but when you actually look at the images, you'll see that the stone is in particularly poor condition. There's stone spalling, there's a lot of erosion, and it's only when you sort of get up and into these things that you can see them. You can't necessarily always see them from the ground, but this is a site that's on the seafront, so it does get quite a bit of salt spray from the beach, and that's so. Obviously, there's a risk that some of the stone could delaminate and fall onto the public, which is something that we had to do to fix. So, we had to repair the masonry. The approach was we brought in British Geological Survey to take a sample of the existing masonry away and do a petrographic analysis. They provided us with a couple of potential solutions, and what we had to do was I think it was Corncockle or Locker Briggs was used in the end, and you'll see in the image on the left-hand side the interventions are kind of fairly clear to see. This, oh, sorry, I'll go back up one. This is a straightforward fabric repair of a project I worked on in Anstruther as well. It's a few years old. It's a particularly poor state of disrepair. There are several issues that maybe aren't quite clear. You see from the medieval tower, there's a tree growing out of it. The parapet, the Harling's in fairly poor condition there. The town hall on the image on the left has got a cement render on it, and the roof was in fairly poor condition. So the further we went up the building, the more and more problems we got to see, which was because it was more exposed, I suppose. And what we had to do as part of this sort of 100-year repair was to clear the parapet and basically take it down, install new stone spouts, and rebuild it again. The cap house was given a lime harl, and it was given several coats of lime wash, and that's the sort of finished building on the finished parapet on the right-hand side. But that intervention will help that building shed water. It deals with the defects of the eroded stone spouts, and that's it today. This is your typical 100-year repair where what we had to do. So that building now, I would sort of argue, is ready for a retrofit. You've dealt with the problems of the fabric. Now you're ready to do a more deep retrofit on it. I'll just aware that of time. How am I for time?
Just 2 minutes left, Graham. Thank you.
Okay. Okay. So, oh, sorry. So this is a wee project in Kilmany. So you look at that and you think, who in the right mind would take that on? But it was a great wee project. There's a lot of character with that building, but you'll see that fabric was in extremely poor condition. It has been neglected for a number of years. The roof had to be taken off, but this gave us an opportunity to do a more deep and considered retrofit. We were back to sort of the very basics of the building, and that's it today. So it's now a home for somebody. So I'm just going to run through very quickly the last slides. So just what to do: careful proportionate details, compatible in scale and craft to existing work, enhancement of performance, use an established palette of materials and techniques. Solutions in a 10 are not our thing. Each building assessed on its merit. Listed building consideration changes implicit in the listed building process, and reinstatement of traditional finishes. Rubble's hard to keep dry. Maybe think about what we can do there. Oh, sorry, I went the wrong way. And it's just really my final thought. Most of us will have different job roles throughout our career, and I would imagine that most architectural technologists at some points in their career will encounter working with an existing building, either adapting it or extending it. I think architectural technologists are well placed to play a leading role in retrofitting traditional buildings, but we have to look at the buildings differently. These need to be part of the solution to climate change and not the problem. And it's important to have a good understanding around the issues, particularly around traditionally built structures. Understand the intervention you're proposing and the impact it will have on the existing fabric. Is it appropriate? Is it suitable? And always just fix what's there first. That's my sort of final thought. And there are a wide range of publications from HES available on the Engine Shed website, and there'll be some links disseminated to you later on, but it's probably easier to find them on the website. Okay, thank you.
That was brilliant. Thank you, Graham. Really brought that to life as well. Really fascinating to hear. And the transformation in the old smithy is quite something.
Yeah, I was aware that at the time I wanted to kind of run through it a wee bit quicker. So,
but that's really great to see. So thank you for that. So now we'll move on to our next panelist. So I'd like to welcome John Stinson from Building Research Solutions, and John is going to talk about tools and workflow for performance evaluation. So John, I will hand over to you.
Super, thanks very much, Lindsay. So I'm going to share my screen. Right, here we go. Should be sharing that, all being well. Right, so hello everyone, and thanks to CSIC and CIAT Scotland East for organising and hosting this Retrofit Knowledge Exchange event. And BRS are honoured to be sharing the stage with speakers with such gravitas in the historic restoration and retrofit environment. Now, I'm going to keep my portion of this event quite short because, like Graham's message, Tanya's presentation on adaptation for climate change has some really important messages, and I can keep my stuff quite short here. But I want to cover 5 topics today, and they'll be mostly nice, succinct take-home messages with some nice images to draw your attention. So these things are the tools that a professional can use when assessing, designing, and evaluating solutions for energy efficiency retrofit projects, the workflow that can be applied to utilize those tools, and then I want to add some kind of cautionary messages about the limitations of those tools, and then some kind of messages about human factors in retrofit projects. And finally, I'll wrap up with a little bit of kind of forecasting of other tools coming down the line to help us capture as-built models for what we're calling design for mass retrofit. Now, a few things before I get stuck into the different tools that can be used. First, if you take nothing else away from my presentation today, I want you to take home this one message. It's a sensible balance of data multiplied by your experience in the field. That's how you tangibly de-risk a retrofit project. So regardless of what any retrofit framework says about risk pathways, the best way to de-risk this type of work is to collate your own data, generate and create your own benchmarks and databases, and then refine your retrofit methodologies from what you're learning on the ground and have done in previous jobs. Second, before I get stuck in, just a little bit of scene setting, building on what Oliver had said during my introduction. Through retrofit technical papers and refurbishment case studies and energy efficiency and building physics journals and conference papers, we've been working in the field of and researching in the field of assessing and evaluating energy efficiency measures since before 2010, and that had a heavy focus on pre-1920 buildings. And whenever we were a part of Edinburgh Napier University, we were also the founding members of the retrofitscotland.org knowledge base website. So first up, tools for designers and assessors of energy efficiency retrofit projects. Now, U values, thermal bridging, control of condensation, moisture movement and air permeability, and also operational energy consumption and carbon dioxide emissions. These are the variables that I'm going to be including under the term tools for energy efficiency retrofit. So many of you here today will be familiar with some of these tools by their software names, but it is vitally important for us to refer to these tools by their BSEN and or ISO numbers, because there are lots and lots of software that claim to be for building physics but aren't designed to the overarching standards. So their outputs can't be readily compared across architecture projects. Now, again, all of these are related to operational energy consumption and consequent CO2 emissions, and we'll cover standards and software for embodied energy and end-of-life solutions in a different time. So there are many parts and subparts to these standards, and the various UK building standards and building regulations refer to many of these parts, but they also leave quite a few of these standards out of the actual text and simply make reference to SAP, RD, SAP, and SBIM. Now, we also have various voluntary methodologies and approaches and standards, which include the Scottish Building Standards, Section 7 of the Scottish Building Regulations. Now, whilst I appreciate that's for new build, there are takeaways from that that can be retrofitted into a retrofit project that allows you to go beyond RD, SAP, and SBIM. So under the same 5 performance variables, here are a range of the software common and used by us and other energy efficiency assessors to inform retrofit designs. Now, this slide simply isn't large enough to include every available building physics software available to assessors and designers, but these are the ones that we know deliver to the standards on that previous slide. So importantly, regardless of the software we have 2 types of building physics tools, and I'm going to call them software as opposed to tools moving forward. So those on the slide with the blue background are what we call steady state calculation software, and those with the orange background are software that we call dynamic simulation software, or often DSM for dynamic simulation modeling. Now, the steady state stuff is more common with a much lower lead-in time, and a lot of these are the staple of new build construction, but they can be readily applied by energy efficiency designers and assessors for retrofit projects. And for whole building energy and carbon calculations, the one on the end there, the far right hand side, it's not quite fair putting the MCM calculators like SBIM and RD SAP beside the dynamic stuff, because that's a bit like comparing Microsoft Paint with Autodesk AutoCAD. Both can produce technical drawings, but which one makes your life easier as a construction professional? Not least because the dynamic energy modeling software also gives you daylight results and daylight factors and looks, but importantly, they also give you thermal comfort values using the Pearson Finder methodologies, which I'm going to speak about in the human factors side of this particular presentation. But now for a word of caution with all these softwares and tools. And this is a message for designers and assessors of energy efficiency retrofit works. The more complex and dynamic modeling software with capacity to simulate over many years using hourly weather files and climate data, they are not always better than your simpler numerical steady state stuff. Now, in many ways, they are better, but without the right input data in the form of libraries using dynamic software can be simply worse than useless. Because if you don't have the right input values and you're using proxy materials and proxy locations, then your uncertainty and your margin of error for these outputs will be huge. And some of the numbers you're using to help de-risk will be misleading. So if you are investing in dynamic software or people doing dynamic simulations for you to de-risk a project, local libraries are key and must be linked to your specific location and supply chain. And using proxy materials does not de-risk your project. It can increase it. So for us, it is quite scary at the moment with all the talk around design for retrofit, just how many training courses are cursing the virtues of the software without doing proper due diligence on which software have, by default, weather files and materials from the UK. Now, there is a fine line and a balance to be found between steady state numerical calculation software and advanced dynamic software. And for modeling purposes, it doesn't need to be a case-by-case basis because that would burden kind of mass retrofit. But it does need, as Graham had said, for the kind of real world stuff, it does need to be an archetype by archetype approach. And the differentiation of archetype needs to be set by the building's original strategy for controlling excessive water and indoor air quality. Now, moving quickly on to the tools available to professionals wanting a holistic evaluation of energy efficiency retrofit projects. So just like the tools for an assessor, I won't be covering acoustics and I won't be covering embodied carbon today. So there are BSEN and ISO numbers for the standards which provide whole or partial guidance for methodologies to carry out and define measurements for U values, thermal bridging, moisture risk for elements, and then whole building air permeability and energy consumption. Now, it's the research and decades of knowledge from industry, trades, academics, and research bodies that underpin most of those BSE and ISOs, but those bodies also provide best practice guidance. And for us and our retrofit research partners, this was born from years before, during, and after the TSB's Retrofit for the Future funding mechanism, of which at the time many of us had advocated the role of retrofit evaluator to be defined and recommended. Now, importantly, and regardless of what training course a person went on or the variety of calculation or qualifications they have, you need to ensure that the monitoring and measurements are being carried out to a relevant BSE and ISO standard. That's key. And in instances where the standard doesn't exist, a person's experience and scope of their methodology must be checked and must be challenged. Now, these are the apparatus and hardware and methods that we and others use to evaluate the energy efficiency of retrofit projects. Now, there are much fewer options in the hardware world compared to what's available in the assessment software world, but you can measure essentially the same thing that you're designing earlier on to give those comparable data sets. U-value measurements, enhanced thermography for psi values and temperature factors, 50 Pascal blower door, 4 Pascal pulse air tightness testing. These are all based in relevant standards, and these are highlighted in blue with a blue background. Groundwater, condensation, moisture movement, and whole building energy generation, consumption, and carbon emissions, the ones with the orange background on this slide, they are based on methodologies that have been developed over many years and applying the fundamentals of building physics to post-occupancy evaluation and building performance evaluation work. And those methodologies are readily known. Now, another cautionary message for those who want to evaluate an energy efficiency retrofit project. Replicability and comparability are paramount for what you're going to be capturing and evaluating. Now, this includes the calibration of your own equipment, placement of the sensors, the error and precision of the readings, the sampling rate, etc. So with or without a BSE and ISO standard, the monitoring regime must be consistent and robust to cater for a range of archetypes that you are and will be working with in the future. And without that integrity, the benchmarks and databases that you want to create will be flawed, and you will be increasing the risk there. So it's very important with evaluation hardware that you have a consistent standard, either a national standard or your own in-house standard, so that your data can be comparable. Now, putting all those tools together into something that looks like a workflow. So this is what we in the evaluation world call enhancing the workflow to close the knowledge loop. And this comes really from the new build world, but has greater and more useful impact for retrofit projects. Now here, if you're considering a workflow like this, there are 3 data points that you want to capture. The first one is by using your evaluation tools and hardware to gather in situ performance values of the relevant parts of a building or buildings undergoing retrofit. And this, importantly, will be your baseline. Then using the in situ baseline data as input variables to your assessment software, that allows you to calibrate your models. So even if you're using the steady state stuff, the in situ data that you capture will help you to increase the accuracy of your results and can reduce that risk and the error in your assessment. Then after the retrofit works are completed, you repeat your evaluation. And this means you have 3 data sets which will be performance evaluated, and you can then performance evaluate your work. But also it's and somewhat more importantly, it helps you then to define those benchmarks and those libraries to help de-risk the next project. And the more you do that on early projects, the less you have to do that on future projects, because there is to be defined a matrix of different archetypes, different ages, and different intervention measures. And there is a streamlined way of doing it. You just have to get a better appreciation of how to calibrate your assessment software. So next up, and towards the very end of the presentation here, I want to talk about human factors. And there's 2 points I want to make here. One about going beyond questionnaires and surveys, and the second one, taking a leaf out of the new build book of quick start guides. But first off, surveys in the form of questionnaires and focus groups, etc., and other qualitative metrics are often leaned on too heavily to define the impact of a retrofit project. Then people start getting bogged down with the erroneous term rebound effect, and fuel bills are leaned on way too heavily to define the impact of a retrofit project. Now, whilst there is a place for qualitative data and fuel bill data, it needs to be normalized, and thermal comfort measurements are a good way to do that. And this gives you the values known as predicted mean vote, which is used to predict the percentage of people dissatisfied. And surprisingly, it's a surprisingly useful yet underused statistic. So many of us, moving on to the Quick Start Guide part of this kind of point I want to make, many of us will be familiar with the Scottish Building Standards Section 7 Quick Start Guide. Now, Glasgow School of Art produced the first written version, and then when I was at Napier, I produced the first video version, because videos are often better for conveying complex information. Now, with an energy efficiency retrofit project, we as construction professionals are fundamentally altering the building physics and the physical characteristics of the generation and/or resistance to the movement of energy. Ergo, we are changing how the occupants need to interact with their environment to control their comfort. Now, whilst I'm not advocating a full Section 7 Quick Start Guide to be applied to existing buildings, but a quick restart guide, in whatever form that might look like, if done right, could be effective to addressing the so-called retrofit rebound effect that people get so upset about. So issues such as overheating, changing control points to regulate thermal comfort are considerable issues that can often plague a good retrofit project. And if not looked at correctly during the post-retrofit evaluation, those sorts of values can skew your results to show that the retrofit was not successful, when in reality it may very much have been. Finally, last slide here, a little look to the future in terms of other tools that we can be using to help us in the quest towards achieving some of our energy efficiency retrofit targets. Now, we're all becoming very familiar with terms such as design for manufacture and design for assembly and design for retrofit and design for deconstruction. And we and others are experimenting with equipment to produce as-built photogrammetry models and LiDAR scanning to produce point cloud models for what we're calling design for mass retrofit. Now, these are especially useful when undertaking large-scale retrofit projects with what can have lots of repeatability. So the image there in my slide, the top middle image, that's not a photograph, that's a 3D model where I can go in and take measurements of that model. I can slice that model in half, and I can take accurate dimensions of wall thicknesses, of window sizes. I can export that into an energy assessment software. I can run multiple scenarios to find the optimal retrofit strategy. And then suddenly, all of a sudden, some of the large and clunky retrofit jobs can start to be optimized, meaning that many of the first and second cuts for material sizing can be done before it gets anywhere near the person's house or home or building. Now, whilst we'll never fully move a retrofit project to being fully off-site, there are easy wins here. Reduced travel, reduced moving materials around the country, reduced visits to the property, reduce disruption, reduce decanting, and importantly, reducing cost, time, and wasting of materials. So that's it from me, and thanks again for everyone's time here today. I hope that has been somewhat informative. So I will now pass back to Lindsay.
Great, thank you very much, John. That was a very comprehensive overview. Really appreciate what, well, certainly for me, it's a complex subject. So great to hear that. Right, we'll now hand over to Tanya, just to say as well, we know we've had some questions coming in, but if you have any questions for Graham, John, or indeed for Tanya in our next question, please get them in. We will get through as many as we can from the Q&A. So now I'd like to hand over to Tanya, who is going to talk about strategies to retrofit and adapt for climate resilience. So over to you, Tanya.
Thank you very much, and thank you for inviting me today. I'm really looking forward to sharing all the information that I have been storing for the last few years. So here's my presentation. So now this afternoon I'd like to talk about secondary glazing market, Glaze and Save and our Envisi systems, and our changing approach to surveying. The business changes that we have made to we've had to make and why, and my views on what's required before any retrofit work is carried out. So the secondary glazing market, it's been very restrictive over the years. Glass systems were the only thing that was available until we came along, and it still happens to this day. The salespeople are more than likely to be commission based, so no sale, no income. So there's pressure selling has meant that this market hasn't been well received by the public. So it's been a real challenge for us to commercialise this, commercialise our product, and to get people to be more open. There is also draft proofing companies out there that make claims are greatly fabricated. So it's been a big challenge for us as we came along. Now, Envisitherm itself is our secondary glazing product. We have a liquid draft proofing product called Envisi-Seal, and we have a window film product called Envisi-Film. Now, the three combinations mean that we can insulate and draft proof any window and any door, whether it's single glaze or double glazed. And very exciting. What we've managed to do is really revolutionary in the market. So Envisitherm has many, many benefits, far more than glass has, and it's much more adaptable in the installation process. So we take a typical single glazed window from 5.5 down to 1.7 of a U value. We also at the same time stop some of the solar gain, 27%. So it means that the property is then cooler in the summer and then warmer in the winter. At the same time, we eradicate all the drafts, but because of the magnetic system, it's then easy to take on and off to be able to get ventilation or access for maintenance or repair. There's also clever other things, such as it stops the ultraviolet coming through, so there's no fading anymore. And the noise reduction performance is outstanding. We feel it's on parallel to acoustic glass. And we find a lot of our businesses over double glazing as well, which we hadn't anticipated when we first started. And it's also fireproof, and I think we know how important that is nowadays. Now, there's also breathable, it's water vapor permeable, and I'm going to talk about that in a little bit more detail further on the slides. So here is an example of a superior energy technology. This is at the Women's Library, and the upper floor windows were insulated with Envisitherm when this was taken with the camera, but the lower windows were not, and I think it speaks volumes. And here are some examples of our installs. So this is working with shutters, discrete inside the frame installs, working with shaped windows, working with wood windows where we match the colour matching. We enable the ironmongery to stay in place. Same with Slimplex systems, allow the windows to be easily opened, such as our easy access systems, and we can do any shape, any size basically. This is a church install here. We're showing our skills of being able to install very large systems, and there I am in front of them there. So basically in the last 7 years we now have developed installation processes to go over any single glaze window of any size and shape, and anything that's required that way. Envisi-Seal is our bespoke and non-invasive liquid draft proofing. Now it fills years of warping have done. So with this crystal window here, you can see the gap. So we're able to fill this with it's a hydroscopic silicon that we use. And you can see in this, the door and the window, it's the same again. So it's all reversible, but it gives a very tight seal, and then it enables us then to often insulate after as well. So our free survey process, this has been a real challenge for us as a business, and it's good for me as a business leader to chat to you today and give you another perspective on it. is actually trying to make a company in this market, and how do we retrofit and all the challenges. So we now have to do a survey in 5 parts. A window survey to actually work out where Invisitherm would sit and work out a price. The window health check to see 17 points of a window, a sort of typical sash and case window, to check that it is in a good state, and if not, what advice we would give. The systems presentation is just so the client actually understands Invisitherm, sees it, holds it for themselves, and thermal image survey to actually have a look at any thermal bridging that may and problems that may occur, and then property condition survey. And this is really due now because of the climate impact. And we never used to do the latter two initially, and we're having to now because of the conditions that we're now facing, which I will show you in some of our case studies. So what we do when we educate our clients, and we have to educate the clients, it's not a case of they're just buying from us, is we talk about U values and we explain the thermal transmission of the U value. We talk about, you know, with the U value, we talk about the radiant surfaces, the temperature, the increased thermal comfort that we can then achieve, and it gets them to understand what their house is all about. And we really do get engagement from them. Thermal bridging, and explain the significant higher heat transfer of surrounding any fabric. Water permeability, the importance of materials that are able to handle the movement of moisture. Now this is a problem, well not a problem, a challenge for us. Our product must breathe, it must be water vapour permeable so that it enables moisture to travel through and is not trapped. But equally at the same time, if we're putting it over a window that is not stable and has got an issue, then we will draw in the moisture. So it's a good health check in itself. It lets our customers know that the window is not stable, but we need to find that out before we do the installation. So it's made another layer for us. So we also talk to the customer about ventilation and air quality, and we explain the traditional build air movement and modern pollution challenges such as traffic canyons. Now, with the condensation and relative humidity, we also loan a free dehumidifier to any of our customers for 3 months so that they can engage with the moisture levels in the home. We are finding, especially in the last sort of 3 to 4 years, that our clients are coming to us and saying that we're freezing. We've never felt this cold before in our home. Our heating hasn't changed. We haven't changed. And what it is the moisture levels within the house have been getting higher and higher. So I would love anybody out there that wants to help us is do some more research on this because there's something going on. And the vast majority of our clients buy the dehumidifiers from us because they find that they need to reduce the levels of moisture within the home. We also share ventilation and heat loss information. So this is a plan that we share with our potential clients about all the different ways that the air can come into their home so that they can understand the airflow, because it's really important to make sure that that is maintained during any retrofit that's going on. And we also look at the energy performance certificate, and we make recommendations on whole house retrofit and not just our product. If the loft insulation hasn't been carried out, for example, that really has to be done first before the windows or in conjunction with that vision, one example. Scottish Government funding, well, is available and we let our clients know how they can apply. And right now, Zero Waste Scotland for commercial buildings has a 30% grant on our product, which is fantastic. And we also demystify the energy savings. Now, this is my background prior to taking on Blaze and Save. And I've talked about this for many years and the stages that you need to go through in order to achieve net zero or a path to energy saving. And there's a behavioural change, which is well documented, and I know John Simpson's knows an awful lot about this area. Low cost, easy solutions, which are simple. Well, behavioural change, by the way, is just simple things like closing the curtains an hour before you get dark. It can actually keep 2 degrees in the house. Moving your headboard from an external wall into the room, or changing the setup of the room. They don't cost anything, but they actually can improve the thermal comfort and your overall utility consumption. Your low-cost solutions are simple things like radiator reflectors, some draft proofing within the house around exit doors. And then you move on to guaranteed payback solutions, and then you look at the high-cost solutions. The guaranteed payback, Invisitherm comes in under that. Over a period of time, the product will pay for itself. High-cost solutions are things like air source, ground source, that have a much higher output. Now, we've added this in. The home must now be watertight before you go to the stage that we're now wanting to install. And this is new advice that we're now sharing, and this is why I'm speaking to you today, to share why we're saying this. So as Graham alluded to, the climate change is here and now and happening, and a dramatic effect. And we are seeing a lot of the gutters that are just not able to cope with the water that's coming down. The downpipes are blocked or simply not big enough. The water is overflowing and hitting onto the windows and having a big impact on the condition of the windowsills. Now, here are some case studies to show exactly what we're seeing. Now, it might shock you, these case studies that I have chosen are simply in the last 2 to 2.5 weeks. I can replicate this hundreds of times over, and this is the sad case, that we're now facing. Now, this property is owned by a lady who's in the construction industry, so very switched on. And when she purchased the property, she had her windows restored, and she's got the property in a very high standard. And as you can see, looking at it, I think you'd agree, this is the ground floor here. It looks fantastic condition. However, on closer inspection, you can see that the stones are suffocating the stone wall. And the water now is rising to the levels of the window, and the windows are really soft. They look great, but you go up to them and your fingers just sink in them. And you can see here, unfortunately, the sandstone starting to come away as well at the window level. Now, this property, they were not aware of this at all until we pointed it out. And again, this is in the same town. The suffocation here in the pavement by the council, and I spoke to the window restorer, who I hold in very high regard, who's actually replacing one of these sills in the next 2 to 3 weeks, and asked him what he thought about this, and he was absolutely shocked to understand where the actual source of the moisture had come from. He doesn't ever actually advise the client, get your gutter fixed. He'll just fix the actual problem and not the source of the issue. And again, this is a 4-year-old window in a church that was replaced. And they said to me, oh, there'll be no problems with any of the windows. And as you can see, Visitherm is drawing in a lot of moisture. All the putty is coming away. And it's a very exposed window out of all the 6 that we installed. Another case study here, and this is a 5-year-old hardwood window. And it's obviously, it doesn't look too bad. It looks like it just needs a good paint. But on closer inspection, we found that there is really, really bad rot. And if you look above, you can see just a small drip that must be hitting the window every so often, and it's causing the problem. But the good news is you can see that you can patch repair this, and you can use things like, apart from fixing the rowing to stop it from happening again, you can also use long life paints, external paints like Demi-Deck, that will give you a guaranteed 12 years. So they don't have to be a burden in the future. Now, this was myself looking into another property, and the client that I was surveying said, it's a pity that our neighbours have had to replace their window because it was so rotten. And I said, they're going to have to replace this window very quickly too, because the source of the problem hasn't gone away. Like Graham had identified, is pointing missing, and you can see the wet drips coming down, and it's been rotting this window. And you can see the moss is still there, so this will have to be replaced again. So no one has actually looked at the source. They've just done what the client wanted, was get rid of my rotten window and give me a new one. And to be honest, all it really needed probably was a sill and maybe a lower sash, and not the whole window. This new wood now is not going to last nearly as long as an original wood window would do. Now, this home was purchased last year at well over £1 million, and the homeowner was given more or less a clean bill of health and told that the house was wind and watertight. Now, you can see from my very brief inspection that that's not the case, and the stone was already starting to get damp around the bay, and the vents had been suffocated through some gravel being laid over the top of the original earth. And on the side of the house, I found with my thermal image a very damp patch, and it's very evident when you take a step back. You can see that this rowing and this downpipe is all blocked. And yeah, it's quite frightening. And this is the side of the house. Now, he was aware of this because he was told this room had slight damp, but he was told just to cut back the trees, and nobody actually noticed that the ground level is getting higher and higher. And also that downpipe that I talked about doesn't quite go in properly. This all should really be changed. And you can see that the bounce back is actually starting to erode all the stone around this area. Case study number 7. This house was only purchased in early spring. And the first lot of rain that we did start to get after a very dry spring, they realised that there's a lot of water pouring in this area here. And you can see that this roof has been piggybacked against this roof here. and this asking this very shallow gutter and downpipe to take all this water. And then the most shocking one of all is this is their main downpipe. It's not even functioning properly, and all this moss is caused by the water that's gushing from this. It's been soaking into the property, and luckily it's not at the window level yet, but it is having an impact on the thermal comfort of the home. And it is starting to erode some of the stonework around, which is really sad to see. Now this case study number 8. Now this block is a factor block. It's quite a large building that's been converted a number of years ago. And when we were surveying the property, I noticed quite a number of things in the thermal camera, and they said, oh no, it's just had the scaffolding up last year, everything's all done, it's hunky-dory, I think was their words. And I was like, don't think so. So I went outside. First of all, you can clearly see that the water there is coming not into the capture, and actually soaking into the stone, and the camera picked that up straight away. Also, the second downpipe is leaking, it's blocked at the bottom, and it's got plants going out of it. And then scary is that the pointing wasn't done, and with this water coming down and probably the wind blowing and the climate change is meaning that these windows are getting hit with a lot more moisture. And you can see this window in particular is already starting to feel the effects of the excess moisture, and the paint that was put on, what, 10 months ago, less than that, is already coming away. So this gentleman was absolutely shocked because he felt that he'd paid for good money to have his building maintained. Case study number 9, I just wanted to show, because of what Graham had said earlier, I've added this one in. You can see the stone building rather than sandstone, it's a stone, but you can see that the actual moisture from the thermal camera is coming all the way through. So that's from previous sort of plant fixings. That's how much that can actually be soaked into the building itself, just like Graham's diagram said. So when we're going out with our thermal survey, we're bringing to life exactly what's happening within the house and really engaging the clients with what's going on. This home, again, was only purchased last year, and at no point was the homeowner told that all his downpipes were soakaways, that there was no drainage at all. And we found the whole base of the house to be terribly, terribly damp. And when we looked at the side inspection, as well as the soakaway, there has actually been a sort of tarmac being put right along the street right next to the home. And it's meant that the moisture now is just running straight into the stone. It isn't able to soak into the ground as it would have done previously. And we found that his vents were also blocked up. Now, when he bought that house, it was given a clean bill of health, and he was unaware of any of this until we came along with the camera. And sadly, with the windows, you can see the water penetration coming down, and it's been dripping over this downpipe here. And I think that's because that simply isn't big enough now to handle all this water. And the window itself is starting to rot along the bottom sill, but luckily we're catching it in time, and we're going to be able to, that will be able to be rescued. That's inside his lounge, and you can see very clearly the damp coming in. Now, why is this the property owner? Is this ignorance of these major issues? I've been racking my brains, especially over the last year, as to why this is actually happening. So I'm glad that I'm having an audience today to put this to. So when it's a newly built property, they're confident of the sales report. Do you think that's why it is? Do you think it's concentrating on the internal aspects of the home first and not actually looking outside? You know, so desperate to get the kitchens and the bathroom and the furnishings and things and the paint right? Not sure. Relying on existing tradesmen to highlight and fix the issues. We outsource everything these days, from dog walking to ironing. Do we think that everybody that we would hire is then able to fix the problems for us? Lack of understanding of tradesmen prepared to work on traditional buildings, or limited understanding of the climate change issues that we're now facing, and fast. Timber preservation companies not advising correctly the source of the issue. I've done some journeying before I spoke today about this, and they just have it in a very fine print that they say that the landscaping, external landscaping, you should be considered. And I've asked landscapers if they've ever really come across any of these reports, and they wouldn't have a clue on how to start. So there's definitely disconnections with everything. Lots of roofers are fixing the gutters, but they're not looking at the blocked drains below. They're just quite happy to clear what is seen and not actually looking and mentioning that there's other problems there. Property owners don't understand the implications of leaving repairs and how quickly things can deteriorate, or the repairs on their own are no longer adequate and that adaptation is required. And that for me is the focus of today. is the repair, restore and retrofit. Is when you're repairing, you repair, maintain and adapt. And when we work with any of our clients, we give out these 3 documents from Historic Environment Scotland that Graham's already shared, and they speak volumes about what is needed to be looked at. And here is the guides that we give out for window maintenance, and these are them here as well, and they're excellent guides and they really do help and inform. We also point people to this website, which is the Sustainable Traditional Buildings Alliance. It's called a retrofit wheel, and it will alert to any unintended consequences if you don't get the journey that you're going on for retrofitting in the right order and with the right products. Whilst it was written in 2013 and it's not been updated, it's still an extremely valuable tool. Now, I wanted to end with these last 3 slides and talk about why I feel this is a really big issue. If we look at this slide from the Institute of Building Physics, you can see here that they've done a sort of a test of a typical insulating product, and that's vapor permeable. And with no errors in the installation of it whatsoever, or no issues with the environment around it, it will draw in 0.5 of a gram of water. With 1 millimetre of a gap, it draws in 800 grams of water. So you can imagine if we don't get it right, what will happen when we do start insulating in buildings that are not watertight. So I'll leave you with this quote. Gordon Nielsen, I heard him speak at an event towards the end of last year, and he said that in late 2020, research that was carried out in 2018 on Scottish House Condition Survey estimated that only 27% of pre-1919 properties are wind and watertight. That's a staggering figure. Now, I would say it's near 90% from the surveys that we carry out. I'm not sure if we're stereotypical or not, but it is staggering. And he really wrote home that we need to repair before we insulate and insulate before we generate. And that is the message that I'm leaving you with today. So thank you very much for listening.
Excellent. Thank you for that, Tanya. Really interesting. I know we'd spoken before the session today about some of the case studies you were going to show, but some of those were astounding, and the fact that they all just happened in the past 2.5 weeks as well is incredible.
They did, yeah. That was why there's a lack of thermal images, because they don't really work at this time of year. so sorry about that.
No problem. Right, great. So what we're going to do now, before we go to the Q&A, we're just going to bring up another poll to give the panelists a quick chance to get a drink of water before your questions. And what we would like to see is your thoughts on what is the most important aspect of energy efficiency retrofit on post-war buildings. So we're talking sort of after 1919 here. And is it the preservation of architectural features, lowest carbon dioxide emissions, reducing energy and fuel poverty, maintaining the use of the building, or using local materials and skills? So we'll leave that up for a few seconds and then get the feedback fairly quickly. And we've got some questions, I've had some questions coming through as well for the panels. Right, so what we've got here, again, reducing energy costs and fuel poverty. It's a bit of a difference there from the first one, where preservation of architectural features was scoring much higher there. And maintaining the use of the building, so high on that one as well. So thank you everyone for that. All right, I'd like to ask could all the panelists put their cameras back on now, and we'll get to the Q&As. Right, great. So first question has come through, and this is for Graham, and this is from Douglas. What are some indicators to identify the differences between cement and lime-based harls? Graham, over to you.
Oh, well, I think the first, you would know what a cement render would look different. It would feel different. But I suppose in some instances, people have put cement in lime harls to make them a wee bit more. I suppose to help them sort of go off a wee bit easier, but it's just a different. It's a different look, I think. In all honesty, you know, if you had the slide up, you would see that the harls are just a wee bit, you know, coarser almost, whereas the cement's probably a wee bit smoother. But there's plenty of guidance in there. You can have a read at if that. I'm not sure if I've answered your question. It's just you kind of know, I suppose.
All right, great. No, thanks for that, Graham. And so the next question is from Stefan. Is the 28 million figure inclusive of new build housing currently designed to the minimum standards that will need to be retrofitted to achieve improved energy performance? And I think that was something I actually referenced in my introduction. So I've been desperately trying to look this up for you, Stefan, and I haven't got quite the answer yet. So if my other panelists don't know, then we'll come back to you. But yes, we are aware that buildings, there are some new buildings being built at the moment where the energy performance could be better and will not be sufficient for the goals.
I was just going to sort of pitch in. If you think about Scotland on its own with 455,000 traditionally built buildings, that's a lot to get through. I think 28 million's, quite a staggering figure. But yeah. Yeah.
So Stefan, I will look up the background figure those figures are government figures. So I'll look at their how they classified the retrofit for that and come back to you on that after the webinar, if that is okay. Next one is a question from Jamal. When it comes to users' health issues and global calls to reduce carbon emissions, shall we compromise with conservation of historical buildings? That's an interesting point. Anyone on the panel who particularly wants to take on that one?
I was just going to sort of say, I think what we've kind of shown is that you don't have to compromise. You don't have to compromise in the architectural features. There's a lot you can do to your buildings before you get to that point. I think that's what I would suggest is if you go onto the Engine Shed website and look at the publications, and there's numerous case studies that Roger Curtis and Moses Jenkins have produced over the years that show how you can thermally upgrade a building without compromising the architectural features. So, I don't think we're quite at that point yet. So I would disagree. I think we don't need to compromise the historical features of a building.
All right, thank you, Graham. John or Tanya, anything you'd like to add to that?
Yeah, I could jump in just for a quick second. There's just building what Graham had said. And we know that the EPCs and the energy performance certificates and such, and that's the metric that we use to performance evaluate our current stock and to kind of drive retrofit solutions. And we know they're a useful vehicle for that because they do normalize and standardize the data for national comparison to do these sort of statistics that we use to underpin some of these events. But there is a kind of growing need to have some of those targets and some of those numbers and some of those statistics and the EPC vehicle itself to be done on a per archetype scale. So telling everybody that for carbon purposes and for climate change purposes that we need to hit a certain EPC, that's probably not as useful anymore as what it used to be. There needs to be a far clearer focus on if you're working with this archetype in this kind of age group, we know that there's known challenges with it, and the maintaining indoor air quality is very important. So here's your set of solutions. There's also some other kind of building performance metrics and tools that are often misunderstood, especially around the air tightness measurements. Now, I know we have to do a certain number of air tightness tests for new build to comply with Scottish building standards, but those tools and other tools that I've mentioned can readily be applied to existing buildings. We just need to kind of turn on the independent thinking, kind of critical evaluation of the numbers we're getting out. And by reducing ventilation heat loss inside those buildings, it doesn't mean you're reducing indoor air quality. It just means that you're reducing the amount of undesigned ventilation pathways for heat escaping, because you close off your strategic ventilation pathways. And as Graham said, there's a phenomenal amount of content out there to how to find the line. The real message moving forward is how do you find that line on scale, quickly and repeatably. That's I think the next challenge. So any advice coming down from top down, it needs to be a per archetype level, not just kind of forcing all of us in the construction industry by saying all these buildings need to be retrofitted. We want to work it out. We need to have a little bit more structure and guidance in terms of building age types and building archetypes.
I could just quickly add as well, for myself, just 3 very clear points. Visitherm is an invisible thermal layer. So we do we do insulate without you seeing it. It's more transparent than glass, so it is invisible. You see your primary window, all the ironmongery, everything on it. We give free air tightness testing for any customer who would or wishes to have this, because we love to have data. We'd love to publish data. So if people are prepared to have that the house, then we will do. And lastly, our homes that we fit in Visitherm in are healthier after the install than they were before, for multiple reasons, which I'll not go into today. But there is many solutions out there that can make the home more healthier and a happier place to live without compromising anything.
Great, thanks, Tanya. Okay, we'll move on to the next question from Stephen. Should past 2035 or past 2038 form the basis of the definition of retrofit, for example, for government funding? John, I think I'd like to bring you in there.
Yes, I've spoken to lots of people about the various different paths at the moment, and it's something that the framework is a useful framework, but again, a lot of us, all the speakers here, many of the people in the audience today have been working in retrofit for the past 10, 15, 20, 30, 40 years. And we've been retrofitting buildings since the Victorians took over from the Georgians and changed the window sizes. We've been doing this for decades, and we know how to do it right, and we know how to do it well, and we know how to share best practice. And whether or not that needs to be defined for kind of tender specifications, yeah, there's an argument there that if you're doing kind of local authority stuff, you're kind of doing mass village scale retrofit, then yeah, arguably the trades and the contractor side need to have some sort of framework to work to understand how to cost for those big projects. But again, it's scalable. You do need to go up and tell somebody like Liz and say of how to be a retrofitter when they've been doing it for the best part of a decade. There's a bit of another line to be found on that one. Just looking at the question again. Yes, in terms of government funding, that's kind of the hook that tied us all in, where if we don't conform to whatever's coming down in these sort of frameworks, if we don't change our business models and change the titles on our signature strips and change all that to show we're doing something, the terminology the government's using, then are we kind of losing part of that part of the sector we should be working in and supporting? It's very divisive frameworks like that come down, especially when there's link to funding. And especially when you're trying to do something good for the building that you know as a construction professional is not good for that building, but the funding is saying you have to choose this thing over here. It's a difficult one in terms of should we be following those for exact definitions. That's my take on it.
Okay, thank you for that. So Stephen, no straightforward answer, but obviously there's a lot to be considered there. I'm conscious we're running out of time, so we'll take one more question. We do have more from the audience, but what we'll do is we'll take them offline and respond to everyone afterwards. And so this is a question from Alison. And this I think will be going to Graham. Do we need Historic Environment Scotland's approval or listing consent if stonemason removes cement and replaces with lime mortar? Are there grants available to help?
So the first thing I'd say, if the building's listed, then I would go and speak to I'd get advice from our heritage management team just to give you a bit of a steer on that. Ordinarily, probably not. You could just do it. But yeah, so if it's listed, go and speak to them. If not, I would just say crack on. But I would get somebody that knows what they're doing with lime, and maybe speak to the Lime Centre in Charleston, get a wee bit of advice from them, because you want to make sure you get the mix right, and they would be able to give you a bit of a steer. But there's plenty of information out there on lime. And with the question about grants, there is a historic repair grant, but it's probably focused more on community groups who are taking over assets and the like. So I don't know if the building you're talking about is your own home, or if it's if it's a building that you are thinking of taking over. But there is grants available there, and you can just get them from the Historic Environment Scotland. You get information on them from the Historic Environment Scotland website and speak to them about it. But usually they're more focused on need and that. So.
All right, great. Thanks for that, Graham. And as I say, I'm sorry, we have run out of time. There are more questions, but we will answer them directly afterwards. So just to finish off, I think we've got one final poll coming up. Is that right, Danielle? Yeah. And we just want to know what metric drives your selection of energy efficient materials for historic buildings in pre-1919. Is it the lowest possible U value, lowest possible air tightness value, hygroscopic properties, the best RD SAP and EPC score, or is it cost? So we'll get the figures up for that in a minute. Also quite a spread there. That's interesting to see. Yeah, so hygroscopic properties doing very well there, as our lowest possible U value, and cost is obviously clearly a factor in that as well, as with most things. So thank you all for attending today. I'd like to thank our panel. Thank you to John, Tanya, Graham, and also to Oliver for joining us early on. Those 3 really great talks. We will be sending out the slides and the presentations afterwards. And thank you for all your questions that you put forward today. We'll answer as many as we can afterwards as well. We will, as I said, we'll send out the links, and we will be sending out feedback. We really appreciate your feedback for that as well. Just a few events that we've got coming up from CSIC. If Passive House, which has been mentioned briefly in this, if you're interested in that, we have a series of Passive House training webinars and practical sessions ongoing, which are these are part of our Passive House in Practice programme, which is fully funded places are available, funded by the Scottish Funding Council. You can find out more about that on our website. And we also have data in construction that has also been mentioned today, the importance of data. We have a session coming up on construction safety and how your existing data can be helped used to lower risks. All details of these can be found on our website as well. So it just means to say thank you again to our panel. Thank you all for attending, and I hope everyone has a lovely day. Bye-bye.
Thank you very much.
Thank you.
Bye.